what's the deal with inverse functions? All right, so what does it mean for two functions to be inverses? F and G are inverse functions if what? What's the definition? Well, okay, that's an example of a pair of inverse functions. Why are they inverse functions? So let's just let's take that example. Okay, that's a graphical way that you can tell, yeah. But algebraically, okay, so what you said is true. What's true algebraically about e to the x and log x? What happens if I plug one into the other? What do I get if I plug it in that way? X. And what do I get if I plug it in this way? Also x. Okay, so that kind of reminds us then the definition. If f of g of x is g of f of x, is x. Okay, so if the two functions undo each other, so to speak, if you compose them in either order, in both orders you get x, they're inverses. Okay, now strictly speaking, if you compose them in one order and you compose them in the other order, could you get different answers? Right, so is g of f of x always the same as f of g of x for any two functions? Most certainly not, right? In fact, do you guys remember the little meme that I posted maybe a few weeks ago? It was f of x was pineapple and g of x was pizza. And yeah, did you guys like that? I've since found a few more that are kind of in that spirit, which I thought were kind of funny. But one of them was, and I'll find it. It was Joseph Stalin and Bugs Bunny. And f of g of x was Bugs Bunny with a big mustache looking like he was Joseph Stalin. And g of f of x was Joseph Stalin in like a bunny outfit. Right, so, yeah. All right, anyway. Yeah, so it's not necessarily the case that when you compose them in either order, you're going to get the same answer. This is one of the nice exceptions to it, though, that if they're inverse functions, it actually doesn't matter which order you do it in. Okay, now we're going to talk sort of about trig inverse functions. And so under what circumstances does a function have an inverse? Okay, so what's sort of the rule for that? Yeah, passes the horizontal line test. Okay, so let's just let's write that out. So under what circumstances does a function have an inverse? Okay, graphically, it passes the Okay, so let me draw two examples, one that passes and one that doesn't. So let's say as my first example, I'll do y equals x cubed. And as my second example, I'll do y equals x squared. Okay, so you guys remember what the vertical line test is probably, right? That's what tells you if you have a function in the first place. So if you imagine any vertical line, how many times can the vertical line intersect the graph if the graph came from a function at any vertical line? At most once. Okay, and I say at most because the function could be undefined in some places. For the horizontal line test, it's the same thing, except horizontal, right? So if I draw any horizontal line, do all horizontal lines intersect the graph at most once? Well, for the first graph, yeah, they do. But for the second graph, the one down there at the bottom doesn't intersect at all. Okay, fine. But there is a horizontal line. Well, it doesn't look very horizontal, but humor me. The one up there at the top intersects more than once. Okay, so that function does not have an inverse. Okay, so let's give this the technical, the college definition. Okay, so a function is called one-to-one if f of x equals f of y implies x equals y. Okay, so what this means is if you have 2 points at which the function has the same output, they had to have come from the same input. Okay, so if we think about our graphs here, that's not true for y equals x squared. Okay, so like let's say that this is y equals 4, just I'm making up a number. 4 equals 4, right? Okay, so f of 2 equals f of minus 2, right? If you square both of them, you get 4. But does 2 equal negative 2? No. Okay, that was a test to see how awake you guys were. And the answer is not very. All right, so no, 2 does not equal negative 2, right? So, so this first, or sorry, the y equals x squared example is not one-to-one, whereas y equals x cubed is, okay? And the reason that we need that definition is because a function has an inverse if it's one-to-one, okay? So this one-to-one thing is basically the technical way of saying the horizontal line test. Okay, and the horizontal line test, I mean, there's nothing wrong with it, right? It's a perfectly good tool, but this is sort of the technical definition behind it. Okay, so does that make sense? Okay, so the biggest problem we're going to have then is what's true about all the trig functions. So if I graph all 6 of those, let's just take sine or cosine for a moment. Right, if I were to graph that, what's the graph look like? Yeah, this business, right? Which is horribly not one-to-one, okay? Because any horizontal line I draw, like this one, for example, actually intersects the graph at infinitely many points, not just 2, right? So that's super bad. Okay, so we can't talk about the inverse of a trig function unless we restrict our attention to only part of the graph. Okay, so let me redraw the graph that doesn't suck. Okay, and so what I'm going to do is I'm going to draw the graph. I'm going to draw just a little piece of it. Okay, the part between negative pi halves and pi halves. And the reason I picked sort of that part, I could have picked a bunch of other chunks, but basically I wanted to have exactly one y value from the entire range that the function takes on, right? So we know sine and cosine oscillate between -1 and 1, right? So I want to pick a region of values where I get all the values from minus 1 to 1 precisely one time. Okay? Now, so I chose to go from minus pi halves to pi halves. Could I have chosen other ranges of x? Okay, so for example, could I have chosen from pi halves to 3 pi halves where it would have been going down? Could I pick that one instead? So why did I pick this one? Peer pressure. Right? We all agree that that's what we pick. Okay, so maybe a better example of this is, what's the square root of 4? Why didn't you answer minus 2? Minus 2 squared is 4. But why did you pick 2 over minus 2? Because that's what, yeah, exactly, the peer pressure, right? You were taught, well, it can only be one of the two values. It can't be both, because otherwise square root isn't a function, right? So which one should we pick, the positive root or the negative root? And the convention is that we choose the positive root. Right? That's just the convention we've all agreed upon for several hundred years. So this is sort of similar. We have to agree, all right, for us to talk about the inverse of the sine function, we first have to restrict the sine function to just part of its domain. And once we've done that, we can talk about the inverse of that part. Okay? And the canonical choice is we all pick this one, okay, for sine. Okay, so between minus pi halves and pi halves. Okay, then on that interval from minus pi halves to pi halves, is this function 1 to 1? Yeah, so we can define its inverse. Okay, and what do we call the inverse of sine? Arcsine. Okay, I do not like sine to the minus 1 as a notation. Okay, because what does that make you think if you see sine to the minus 1? Which is cosecant, and cosecant is not the same thing. Okay, so I don't like to write sine to the minus 1 because it causes confusion, exactly. Okay, so I prefer to write arcsine, and then we don't have the problem. Now, that said, you guys will see in books and, you know, particularly those of you guys who want to go on to like physics or engineering, right? You're going to see the sine to the minus 1 notation. Like it's out there. That is a standard and valid notation. I just don't like it. Okay. So just be careful. That's the one exception to the rule. Which I guess maybe I should say, think of this like the way we write math, you know, sine to the minus 1 is a kind of ambiguous notation, right? Like you might think it means when anything else is to the negative 1, which is to do 1 over that thing. But this is an exception, right? Well, how many times, like you guys have all studied foreign languages, right? What languages? Spanish mostly, right? And some German, right? Are there weird, like, irregular verbs that don't follow all the rules? Every friggin' language has one of them, except maybe Esperanto, okay? Which was deliberately constructed to not have irregularities. So, yeah, every human language has irregularities in it, and this is one in math language, okay? All right, so c'est la vie. Once we restrict the domains, we're good. We have inverse functions. All right, now, the standard restrictions for the other trig functions are listed there on the sheet. So cosine, we go between 0 and pi. Tangent, between negative pi halves and pi halves. But, of course, tangent, what's the problem at pi halves or minus pi halves? What's tangent of pi halves? It's undefined, right? So if I were to graph tangent, what would I have there? I'd have some vertical asymptotes. Okay, so the difference between sine and tangent is the square versus rounding parentheses. Okay, okay. So are we Gucci with sort of the definition of the inverse trig functions? Okay, and of course, what's the whole point of why we're here today is to talk about the calculus with these things. Right? So you should have all seen inverse trig functions in high school at some point. Right, okay, so good. All right, so let's figure out what's the derivative of arc sine. All right, so how am I going to do this? So if I'm going to say y equals arc sine of x, and I want to answer the question, what is the derivative dy dx? Well, I don't know jack crap about arc sine. That's the whole problem, okay? But I do know a whole lot about sine. So how could I turn arc sine into sine? Basically, yeah, exactly. Switch x and y, okay? So what I'm going to do is say, well, what does y equal arc sine mean? It means x equals sine of y and, y is somewhere in the interval between minus pi halves and pi halves, okay? X would therefore be something between minus 1 and 1, okay? So that's the technical definition. Yeah, question? Okay, it switched because, so let me go back to my graph. Oh, did I write it the other way? Oh, hang on. X equals sine y. And, oh, yeah, that should be y. Yeah, sorry. It's a typo. Yeah, y is in this range, x is in, that range. Yeah, okay, thanks. Okay, and sort of the way to think about this is, what do you plug into sine? What kind of numbers? Well, okay, let me rephrase. You plug angles into a trig function, right? Yeah. And what comes out of the trig function are numbers, right? So the inverse trig functions, you put in numbers and they spit out angles. Okay. Yeah. All right. So are we good with the flip-flop here? Well, if x equals sine y, I have an equation. Can I take the derivative of both sides? Sure. What are we doing now? What kind of differentiation? Yeah, this is implicit differentiation, okay? So what's the derivative of x? That's easy. What's the derivative of sine of some stuff? Cosine of the stuff times the derivative of the stuff. Okay? So that actually wasn't too bad compared to some of the ones we did last time. And then what do we want to do? We want to solve for dy dx, right? So what do I need to do with the cos y? Just move things around. Okay, so dy dx is 1 over cos y, which is the same as secant of y. Okay, are we finished? We could say yes, but not really, because what was our original function? It was in terms of x. I have an answer here that's in terms of y. Well, that's not good enough. Okay, so what do I need to do? I need to rewrite this stuff back in terms of x. Okay, and the only reason well, okay. In the implicit differentiation stuff, you don't always have to at the end. In fact, sometimes you can't, right? Sometimes there's nothing you can do but leave the answer in terms of x and y. Sorry. In this case, though, we can change this back in terms of x because the whole thing started in terms of x. Okay, so in order to do that, what we need to do is we need to come back to this piece and ask ourselves what that means. Well, if sine of y is equal to x, what is sine? Like think back to when was the very first thing you learned about sine of anything? Oh, before that, right? Even like in geometry, forget trig. SOHCAHTOA, right? Yeah? So what is sine if I have so if I imagine I have a triangle and I say, well, if I'm taking sine of y, then y is an angle in this triangle, so let me put it here. What is sine of that angle? It would be whatever the opposite thing is divided by whatever the hypotenuse is. Okay? Well, what is sine of y supposed to be equal to? It's supposed to be equal to x. Right? So how could I label this side and this hypotenuse so that the ratio would be x? Well, the cheap way would be just put x there and a 1 there. Does that work? Yeah. The opposite over the hypotenuse is x, which is what we said it had to be. Okay, does that make sense? Now, the reason I wanted to do that is because, not because I care about sine y anymore, but I actually care about cos y. Well, in order to figure out cos y, what else do I need to know? I need to know this adjacent side. Okay, well, if only there were a way that if you knew 2 of the 3 sides of a triangle, you could find the third one. And if only this were a right triangle at that. Who rescues us? Yeah, our good old buddy Pythagoras. And we get that, right? Square root of 1 minus x squared. Okay, so in that triangle, what is cosine of y? Well, what's cosine in right triangle? What's SOHCAHTOA say? That's sine. I want cosine. Adjacent over hypotenuse. So what's the adjacent side? The square root. And what's the hypotenuse? And I'm doing 1 over that, right, because I had 1 over cosine. All right, so I've got 1 over a fraction. What does that mean I need to do? Yeah, flip it, right? Yielding that. Now are we finished? Yes. Okay, because we have it in terms of x again. Okay, so recap. What's the TLDR? Okay, it's that. You guys know what TLDR stands for? Too long, didn't read. Okay. Right, so there we go. All right, so flip over to the next sheet, or the next page, sorry. And what I'd like you guys to do is try this for arcsine and arctangent. So let's see, why don't we just sort of alternate, or sorry, not arcsine, cosine. Cosine, tangent. Jose, cosine, tangent, cosine, tangent, cosine, well, champ, you have to do both of them. Okay, got it? So work out your assigned thing, and then we'll come together and make sure that we're clear on both of them. Okay, so we'll take a brief pause while I see what my sister is texting me about. if you forgot that, how could you figure out the answer if Mr. Burns wasn't sitting here and happened to just know? How did we determine that in the first place? And then we did the quotient rule, right? So, now that said, you will firmly commit these to memory just like your unit circle so that we don't have to have a punishment quiz. I'll turn this calculus classroom around right now. I'll do it. No? Okay. My sister says, have a good class. Yeah. They say thanks. And just by way of reminder, my sister is married to a cop, so, and my dad's a Marine, so don't get any ideas, gentlemen. Huh? Like about being like, oh, Dr. McKinney has a sister who is a female, and most of you like females. Yeah, well. I had to be a little bit more on guard when she comes to visit, but not really. Believe me, she's dealt with plenty of dirt balls in her life. 900 Wabash men is no challenge. So, all right. So, we guys get the hang of this? Not really. All right. What does y equals arc cosine of x mean? It means x equals cosine of y, and that the y has to be on what interval? Now, it's different for cosine than sine, so what do we have on the front? Sorry, it's 0 to pi. Okay. So here's basically the issue. We need to have a quadrant represented where the trig function is positive and another quadrant where it's negative. Well, what functions are positive in quadrant 1? Trig functions. Which trig functions are positive in quadrant 1 for quadrant 1 angles? All of them, yes. Which functions are positive in quadrant 2? sine, and therefore also cosecant. Quadrant 3. Tangent. And the reason it's tangent is because, well, here, let's write it this way. Cosine, therefore, in quadrant 4. So sine and cosine are both negative in quadrant 3, and tangent is one of them divided by the other. Well, if you divide a negative by a negative, what do you get? A positive, so we're Gucci. Okay, ASTC. Do you guys remember that from high school? No? So when I was in school, my teachers said, you know, a smart trig class, or all suckers take calculus. Or my favorite, personally, is I taught some high school kids over several summers when I was in grad school, and I showed them that, and they're like, oh, yeah, it's the chipmunks. And I'm like, excuse me? And they said, yeah, Alvin, Simon, Theodore, chipmunks. And I was like, oh, okay, that's cute. That's cute. They're the same ones who taught me soap for the sum and difference of two cubes, right? Like, I just knew the formulas, but they're like, oh, yeah, it's soap. So I'm like, well, excuse me? And, yeah, so anyway, so that's who's positive where. So when we picked which quadrants we restrict our attention to, we're always going to pick quadrant 1, because that gets the positive part for all the functions. And so the question is, do we pick quadrant 2 or 4? Well, that depends on the function. We pick quadrant 2 for cosine, because it's negative there. We could have picked, well, we couldn't have picked quadrant 4 because it would have been positive. We don't need 2 quadrants where it's positive. That wouldn't solve our problem. Okay, so that's sort of the method behind the madness here. Okay, then we need to start differentiating implicitly. Okay, so what's the derivative of both sides? Well, what's the derivative of x? 1, that's easy. What's the derivative of cosine? Negative sine times dy dx by the chain rule. Okay, and so if I solve for dy dx, I get negative 1 over sine of y, which is cosecant of y, but who cares? Okay, so that part kind of goes similar to the last one. All right? But do I know a damn thing about sine of y or cosecant of y? Nope. So we need to draw our triangle. Okay, and that means we need to come back up to, yeah. Okay, so who's the angle this time? Still y, so let me just put him here. Right, it actually doesn't matter where you put the angle. It just, if I chose the other angle, the other non-right angle, then who's opposite and who's adjacent changes. So I typically just pick that angle, the one that's horizontal, but that's not a big deal. Okay, what is cosine of this angle supposed to be? It's supposed to be x, right? What is cosine of the angle in the triangle? Adjacent over hypotenuse. So I need to pick a value of the adjacent and the hypotenuse so that their ratio is x. What's the easiest way to do that? X and 1. Okay. Could I have done 2x and 2? Sure, but this is simpler. Okay. All right, so we're cool with that part. Oui? All right, now I need to know something about sine of y, or cosecant. Well, sine involves the opposite side. Do I know what the opposite side is? Not yet, but can I get it? Because of our buddy Pythagoras. Okay, so what's him? square root of 1 minus x squared. Okay? And so if I substitute that in, right, sine is what? Opposite over hypotenuse. What do I get? Well, I got double fraction foo going on here. So now what? Flip and multiply. And I get the negative of 1 over the square root of 1 minus x squared. Which looks a whole lot like the last problem. We just got the negative instead of the positive answer. Well, that's kind of interesting. Right? Sometimes things work out in mysterious and unexpected ways. Keeps life interesting. Okay, so does that make sense? Now we need to do this next one, the thing for tangent. And for tangent, I'm going to be the world's stupidest note taker. You guys are going to tell me what I'm going to write. So y equals tangent of x. What do I need to write next? Means tangent of y equals x, and what else do I need to write? Yes, those things. I have never heard those called soft parentheses. No, it makes total sense. I've just never, ever heard anybody say that before. Yeah, I mean, now I kind of want like 600 thread count parentheses, but no. Okay, I got a chuckle out of that one. Come on, guys, right? That's not a dad joke. Well, yeah, I don't know. That's like a Will and Grace dad joke, okay? But, yeah. Because let's just put it this way. My dad is most certainly not considering the thread count of any of his sheets. Okay. Yes. All right, so got that so far. Now what?
Take a derivative.
Okay. So tell me how I'm going to write that.
d over dx of tangent y equals d over dx of x.
Okay. And just to keep life interesting here, this equality has things reversed, but whatever. Okay, good. Okay, so on this side, yep, secant squared y times dy dx. And Mr. Silas, what about the other side? No, we already got that one. This one. 1, okay. All right. Gave you the easy side for the 360 no scope. Although I guess I already used that joke last time, so yeah. Okay, now what? Mr. Grimmett, what's next? What? Mumble. We're done with the derivative taking, so now what? Not yet. But one step before that. Yep. Just solve for dy dx. And what, pray tell, is 1 over secant squared y, Mr. Grimmett? Can you simplify that expression? I need one of those like Actually, keep talking. Yeah, phone a friend.
I got 1 over cosine squared.
Yeah, there you go. So, what does it simplify to, Mr. Grimmett?
Cosine squared.
Yeah, wow, that's nice. Let's see, where did I put this? I have a little folder of apps on my phone called Silly, and it has precisely 2 things in it, or 3 things in it. Right. There we go. Okay. So cos squared y. Now what do we do? Our triangle. Okay, so I'm going to draw a triangle, and it's a right triangle. So I need to start labeling things. So where's my angle? I'll put it the same place we always have. Okay, what do we know about this triangle? We know this. Yes. Right, so what's a good way to label this so that happens? Yeah, let's put x here and 1 there, because the ratio of them is supposed to be x, and last time I checked, x divided by 1 is in fact x. Okay, what does that make the hypotenuse? Yeah, we get a plus on this one. Okay. So cos squared of y is something squared. Well, what's the cosine? Right? Okay. Because cosine is what? In SOHCAHTOA. Yeah, adjacent over hypotenuse. So it's that. The thing in the parentheses is the cosine. But of course, we had that thing squared. So what happens to the square root? Disappears. Okay. So let's recap the 3 results that we've discovered today. Oops. Okay, so we have that. That's what we've discovered. Now, why don't we have arc cotangent, arc secant, and arc cosecant on this list? Well, the reason is, if you know that, if you know something about cosecant, then you do also know something about sine, so you can just use the sine one, right? And so, I mean, yeah, we could do the same sort of exercise for the other 3, but there's really no need because sine, cosine, and tangent is enough. We can always rewrite things. Okay, so the last thing there on the sheet, let me just write it down on the bottom there, is we can generalize this to any pair of function and inverse function. And the result is this. Okay, so if you want to know what the derivative of an inverse function is, it's 1 over the function's derivative with the inverse plugged in. Okay, yeah, that I personally have never found to be a super useful result. I can't imagine any time I've actually used that result, but it's certainly true. Okay. Yeah. Okay. So, what I would suggest you guys do then is the next page has some sort of practice problems. So take a crack at those. Maybe Champ, those would be fantastic choices for a future SI session. Yeah? Or some of them anyway. Yeah? But since we're almost out of time, I wanted to make sure we're all on the same page about vendredi cette semaine. Namely, what's happening vendredi cette semaine? This week. Yeah, Friday this week, right? What are we doing on Friday? Yeah, it's a learning celebration, right? We get to celebrate all the awesome stuff you guys have learned. Okay, what is the last section that will appear on there? The chain rule, which is what we did on Friday. Okay, so what we did Monday and what we did today won't appear on this one, they'll appear on the next one. Okay, I guess the other thing to say is we've gotten to the point where we've done enough standards that your stack of problems may be longer than you could do all of them in one sitting. Okay, that's okay. I would rather you do 3/4 of it and nail all 3/4 than half-ass the whole thing. Okay, so give me full ass, not half-ass, please. Yeah, and so it's okay. If you don't get to a problem or you don't remember how to do it, that's fine. I nail the other ones, okay? Because how else can you take assessment besides on paper in classes? Well, with me, right? You can do an oral exam with me for 2 standards a week, remember? Okay, so, yeah, good? All right, see you guys on Friday.